Okay, so I'm going to be explaining how to name ionic compounds and take it from a formula to nomenclature. So the first step is to write out the names of the positive ion followed by the negative ion. So each ionic compound is made up of a cation and an anion. The cation and the cation always comes first. So in this case, for calcium and fluorine together, calcium is the cation and the fluorine is the anion. So the first step is to write out calcium and fluorine. Then the next step is to change the name of the monatomic anion to end in "ide." So the correct way to name this ionic compound would be calcium fluoride. This is a really simple one, so I'll explain how to do it as they get more complicated. There are a lot of exceptions when ionic compounds are formed with metals that have multiple cations or oxidation numbers. So these are mostly the transition metals and then also the group 4 and 5 elements. So in these cases, we use Roman numerals to show their charges, and we find the charges of the elements using like reverse crisscross to find the charge. By looking at the anion, we can find the charge of the cation, which we then show through Roman numerals. Monatomic ions are written like this. So the cations, you just write out the name of the element as is. So Na1- would just be sodium. And then anions, you change the end of the root to end in "ide." So for example, Cl, so chlorine, Cl as an ion would be Cl1-, and then you would just change chlorine to be chloride. So you add the "ide." And then for transition metals groups 4A and 5A, it's the same as when they're inside of the ionic bond. So you deduce the charge using and show that using Roman numerals. Polyatomic ions are a little more tricky. So there's like lots of different layers. So some polyatomic ions we're expected to memorize. So those are the ones that we highlighted on the polyatomic ion chart that we were given in class. So if you see a polyatomic ion in an ionic compound and you recognize it, you write the name as is. If you don't recognize it, there's two things you can do. You can either look at the polyatomic ion chart to see if it's written on there, or you can follow these rules. So polyatomic ions preceded by hydrogen, you add the prefix "bi" to the name of the ion. So for example, carbonate, when it has an H in front of it, hydrogen in front of it, changes to bicarbonate. And the charges change because it has a different chemical makeup, but you add this prefix. But the more hydrogens are added, you add the prefix like di or tri, and you keep moving up as more hydrogens are added. So to name those preceded by oxygen, we follow the elbow rule. So inside the elbow, the eights have 3 oxygen and the ites have 2 oxygen. And outside the elbow, the eights have 4 oxygen and the ites have 3 oxygen. And the order of the eights and the ites goes hyperrudite with the least, to rudite, to rutate, and then to hyperrudate with the most. So I can give a couple examples of that. So for example, if we're looking at sulfur, which is number 16 on the periodic table and is not inside the elbow, so it's outside the elbow. If we want to find sulfate, we look here, and 8 has 4 oxygen. So that would be SO4. But for hyperrudate, we add 1 oxygen to this. So for hypersulfate, we would look at sulfate and add an oxygen. So that would be SO5. It's also similar for the ites and the hyperrudites. So for sulfite, it'd be SO3 because it's outside the elbow and there's 3 oxygen in the ites. But for hyposulfite, we would subtract 1 from this 3, and that would give us SO2 for hyposulfite. For an example, for an element that's in the elbow, we have nitrogen. So nitrate has 3 oxygen because it's inside the elbow, and hypernitrate has 4 oxygen because you add 1 to this 3. Then nitrite has 2 oxygen, and hyponitrite has 1 oxygen. So that's just NO because you subtract 1 from this I of 2. So when you see polyatomic ions inside your ionic compounds, you can follow these rules to try and figure out what they are. So if you see SO4, you can think of if it's inside the elbow or not, and then follow these rules. So I have 4 examples to kind of demonstrate all these ideas. The first one I already showed, calcium fluoride. You just write out this cation as it is, calcium, and then change the end of the fluorine to end in ide, since it's a monatomic anion. Now, number 2 is a really good example of what to do when you see polyatomic ions. So NH4, we know, and we had to memorize as ammonium, so we recognize this one. But silicate, we don't recognize. This one doesn't follow the elbow rule, so we look at our polyatomic ion chart first to see if we can find it. So we can see that silicate's on the polyatomic ion chart as SiO3. So this shows that the order is important. First, you see if you've memorized it, then you look at the chart, and then you do the elbow rule, because the elbow rule can be inaccurate with the ones that are exceptions, which is why they're on the chart. So that's ammonium silicate. And since this is a polyatomic anion and not a monatomic anion, we don't change the ending, and we can leave it as silicate. The third example shows what to do when you have a transition metal. So this is copper 2 chloride, but to find these Roman numerals of 2 to show the charge, you have to do some reverse crisscrossing. So the charge of chloride is -1, which is why there's nothing in front, there's no subscript in front of this copper. But there is a subscript in front of the chlorine. So this 2 came from the copper. That means that the copper has a charge of 2+, which we show with the Roman numerals copper 2. And then since the chlorine is a monatomic anion, we change the ending to ide. So we get copper 2 chloride. Finally, the fourth example is the trickiest. It shows us what to do with polyatomic ions and with transition metals in your ionic bond. So first of all, we can see that this polyatomic ion is similar to phosphate. So we had to memorize phosphate as one of the ones we just had to know, and phosphite is one down from that. So instead of being PO4 like phosphate, it's PO3, which means it's phosphite. And that polyatomic ion we know has a charge of 3-. So that 3- comes from up here to down here. And since there are no parentheses around the phosphite, that means that this copper can only have a charge of +1 because there's nothing else, no more subscript around the phosphite. So that leads us to see that it's just copper 1 phosphite. Thank you.